Hi, I'm Jay Kreps. I'm the CEO of Confluent and one of the creators of Apache Kafka. Today I'm here to talk about something we're calling Project Metamorphosis and share a few really exciting product announcements. And like a lot of you, I'm doing this from home over a webcam. So Project Metamorphosis, what is it? Well, I think there's two really big paradigm shifts that are happening in the world of data right now. The first is one that Confluent is known for, it's event streaming. We think that event streams are a real revolution in how we think about and use data, and we think they're going to be at the core of one of the most important data platforms in a modern company. This is what we would call an event streaming platform. It acts as a central nervous system that ties together applications, data systems, services, SaaS products, and it lets companies tap into and harness the stream of activity data that their business runs on. Our goal at Confluent is to build the infrastructure that makes that possible and help the world take advantage of it. That's why we exist. But event streaming isn't the only change that we're in the midst of. Another equally big one comes from the movement to the cloud, and that's cloud-native data systems. I remember in 2008 spinning up my first EC2 instance, and it was kind of magical. The idea that you could get servers and data storage and all the foundational ingredients of computing on demand and just pay for what you use. That was obviously a big deal even then. But the second order impact that this has had on how applications are architected and how data systems are built and consumed is even bigger. These days, we expect a lot more out of data systems. We expect a modern cloud-native data system to fundamentally simplify the user experience. We expect it to abstract away implementation details like servers and let us scale transparently across data centers around the world. So these are the two paradigms. But if we're honest, although these two things are both happening in the world, they aren't necessarily happening together. Most people's experience of event streams is with Kafka. And Kafka is, well, it's not very cloud-like. It involves configuring Zookeeper, managing data placement, tuning garbage collection, and fundamentally managing a lot of individual servers. That's what Project Metamorphosis is about. It's about bringing those two things together. We think it's time to fundamentally reimagine what event streaming can be in the cloud and provide an experience without all the incidental complexity and the manual labor. The fact is, systems built for the cloud are different in foundational ways, and the experience of using these systems is simply much, much better. We want to bring that to people's experience of Kafka. Over the next 8 months, we'll be announcing a set of product features and improvements to accomplish this goal, one each month. We've organized our announcements around what we think are the 8 foundational traits of cloud-native data systems. Each of these traits on its own can seem like a small thing, but taken together, we think it's a real transformation. The capability that we're kicking this off with is arguably one of the most important in the cloud, and that's elasticity. In the cloud, we expect data systems to be seamless and transparently elastic. They should scale up when we need them, and they should scale down when we don't. And since we don't know exactly what we're going to need ahead of time, we should pay just for what we need and use. This is maybe particularly important right now as we're living in really uncertain times. We've seen some of our customers needing to scale up significantly to meet growing demand or scale down to manage costs. So what are we announcing? Well, we have 3 tiers in our cloud offering. We have a basic tier, a standard tier, and a dedicated tier. And the basic and standard tiers already scaled elastically, up to 100 megabytes per second. And this is done transparently. You don't have to do anything. You just use the service and it gives you what you need. But in our dedicated clusters, we didn't have that. And today we're announcing our dedicated clusters will now support elastic scaling with self-serve provisioning and expansion. And this scales up to gigabytes per second. And you can dynamically create clusters, you can grow and shrink them as you need more or less capacity. And Confluent Cloud will do all the hard work of balancing the load and moving the data placement around within the cluster to take advantage of the capacity that you have. And Confluent Cloud, it's not just Kafka. We actually want to cover the full ecosystem. And our offering of Kafka Connect, which gives you fully managed connectors that connect into cloud data systems or other databases, this scales elastically as well, allowing you to dynamically add and remove capacity as your needs change. We'll be doing the same thing with our offering of KSQL, which will allow adding dynamic scalability over the next few months. This way you can scale up and scale down the processing capacity for your queries while they run without interrupting them. But we're not stopping there. We don't just want these to be scalable. We want the scaling to be done for you. Over the course of this year, we'll be working on making these systems autoscale so they can automatically expand and contract to meet your needs and reduce the cost to you in running them. All of these capabilities are built based on your usage. You can dynamically create new clusters of any type, expand their capacity, add connectors and stream processing, and tear them down if you don't need them. And you'll be built for just what's there, just what you used. These capabilities aren't just for Confluent Cloud either. We're going to be bringing these on-premise and into the private cloud. In our next major release of Confluent Platform, we'll support automatic data balancing and placement within Kafka clusters. When combined with Confluent Operator, which supports operations on Kubernetes, you can get a similar cloud-like elasticity in the private cloud and on-prem environments, allowing you to dynamically launch and expand clusters on demand and get that same data balancing capability natively within the clusters. And some of the work that we're doing to make this possible has spillover even into Apache Kafka itself. So some have heard of what we call KIP 500 that's working on removing the dependency on Zookeeper. And this is really important to support elastic usage patterns. Zookeeper is Kafka's biggest bottleneck, and the dependency on Zookeeper, which is really kind of a legacy component, makes elastic operations difficult. This effort to remove that is very active. Design work is happening, code is being written, and we believe that these changes will make it possible to dramatically scale up the number of partitions and topics that Kafka can support, as well as significantly simplify the operations for those self-managing Kafka by making it a single self-contained deployment without multiple tiers that all have to be tuned and secured independently. And this is going to enable a pretty ambitious goal that we've set for ourselves of having a working Zookeeper-free Kafka that can scale to millions of partitions by the end of the year. So let's take a closer look at these things. Tim Berglund, our Director of Developer Advocacy, will show a demo of some of the features I just described. Tim?
Hey, thanks, Jay. I want to show you how easy it is to scale a cluster in Confluent Cloud. I'm going to create what's called a basic cluster, which you can do on your own with nothing more than an email address and a credit card. What you will not see me doing is any cluster sizing at all. There isn't anything I have to do to a basic cluster to get it to scale as load increases. And there's no hourly cost apart from data stored and data transferred. This is difficult to demonstrate because watching an idle cluster sit there and not cost anything is, well, boring. But the point is that the price you pay is determined entirely by what you use. So I'm logged into my account and I'm going to add a cluster. Here are the only choices that I have to make to do that: a cloud provider, a region, and a type. As I said, I'm picking a basic cluster. And notice the base cost over there on the right, 0. You incur charges only by storing data or writing or reading data. If you don't use the cluster, it doesn't cost you anything. If you've ever heard people say that a cloud service scales to 0, this is what they mean. Now I'll launch that cluster and then get started getting the command line interface set up. I'm going to go through some of the basic steps that are given for me in the Confluent Cloud UI. Setting the environment, the default cluster, creating an API key, and don't worry, I've replaced that key by the time you're seeing this. And now finally, I'll create a topic. And now I'll produce some data to our test topic, then consume it back out. Kafka confirmed. Because I don't know 100 megabytes per second worth of poems, I've got a distributed loading tool that's connected to our cluster to help us out with the next step. Right now, I'm ramping up to 20 megabytes per second of write and read traffic. I'm showing you this in the Confluent Cloud Cluster Overview, which is just an awfully convenient way to see aggregate metrics on your cluster. If you wanted more detailed information, we do expose a metrics API that lets you see a lot more than this. You can integrate this API into your own observability tooling and create any views and alerts you need. But back to the overview. It updates once a minute, so I'm speeding it up a little bit just to keep things interesting. You can see the cluster has scaled automatically from its 0 cost initial state to now passing 20 megabytes per second from our test producers to our test consumers. If we look at the billing tab, we can now see that we're incurring just some slight costs since there's traffic. And looks like I got a few clusters on my account from previous tests. I should look into that. Now let's increase the load to 100 megabytes per second, which is the limit for a basic cluster. You can see the traffic happening here. Once again, I'm speeding this up, but I'm not hiding any of the click here to scale up your cluster buttons. I never had to leave this screen. Scaling just happens automatically. And this is a Kafka cluster that has brokers managing partitions and doing the work of reading and writing data. But I don't have to think about any of those details. Now, I've mentioned basic clusters, but there are also standard and dedicated clusters. Basic clusters, like the one so far in this demo, are great for development, testing, and relatively less mission-critical production workloads. They cost less to operate and they scale to zero, but they aren't covered by uptime SLAs and the durability that comes from replication across availability zones. Standard clusters are like basic clusters, but are replicated across availability zones and are covered by a 99.95% uptime guarantee. Dedicated clusters are fully customizable clusters intended for running mission-critical workloads at any scale, even exceeding a gigabyte per second. They also have additional security and compliance features like, for example, VPC peering to other network resources. I want to show you something new with the way dedicated clusters scale. Here I'm provisioning a small one with just a single CKU of capacity. What's a CKU, you may ask? Well, that's Confluent Cloud's provisioning unit. It just corresponds to a certain amount of ingress and egress traffic, a certain amount of storage, and other guarantees like those. They're all documented. There's a link in the UI, and you can see the details for yourself. It used to be that to expand a dedicated cluster beyond its initial size, you had to file a support ticket and ask a human to help you. Now, as you can see, I can just use the web interface to ask for however many more CKUs I want, up to the maximum. Here, I'm just increasing from 1 to 4. But hey, that's a 4x increase. Business must be good. The best news is you can try all of this for free right now. Go to confluent.cloud in your browser, sign up, and you get $50 in usage credit to get started building things right away. Jay, back to you.
All right, thank you, Jim. Well, if you want to learn more, here's a link to a blog which will tell you more about what we've released and dive a little deeper into some of this stuff. This is just the first release of Project Metamorphosis. We're going to be doing one of these in the first week of each month for the rest of the year. So stay tuned. We have more exciting stuff coming. Thank you.